Vectors have a few different options for multiplication. We already looked at scalar multiplying. There's dot product, which we're going to look at in this video, and then there's also cross product, which is another day's lesson. Dot product, the important thing to realize is when you're multiplying the two vectors, you're going to multiply the different components together. So similar to matrices, a little different. This is a little easier actually. We're going to do A1 times A2 plus B1 times B2 plus C1 times C2. Your answer is going to be a number. That is very important. It's not a vector. But similar to how we did adding component-wise, same thing. You're going to multiply the horizontal together, vertical together, and then the depth or third dimension together, and then add them all up. So it has that similar thing to matrices where we added up our quantities. We're going to do two quick examples before we look at one of the applications of it. So if we're doing v dot w, we're just doing 2 times 5 plus negative 3 times 1 plus 4 times negative 6. The only thing to be careful of here is if you have one of the letters or variables missing, to make sure that you multiply the like ones together. And then you just combine it, you're going to get an answer of negative 17. Here we have a scalar multiplying. All I would probably do with this is just rewrite the two vectors, multiply it out. That way you have the correct values that you're multiplying. Then we're going to multiply component-wise. And then add everything up. So on its own, dot product's kind of boring. Just like the other vector operations, fairly easy. As long as you can multiply and add, you're good to go. The application part is what's going to become a little bit more important for this. So we're first going to look at the angle between vectors, and then in our next video we're going to look at some other applications. So in our angle between, we're doing cosine theta equals the dot product over the magnitudes. Now if you remember from the last lesson, it's important to divide out the magnitudes to get that unit vector. So you're really doing the dot product of two unit vectors. Why is it important for these to be unit vectors? Well, if you remember back from our days of doing our sine and cosine graphs, our range for both of those graphs was negative 1 to 1. So we can't have a magnitude, or we can't have a magnitude for the vectors that's greater than 1, which is why we need to work with the unit vectors. There are two special situations. If you come out with a theta of 90 degrees, the vectors are what's called orthogonal. That's just the vector word for perpendicular. Can't spell perpendicular apparently. It's 2 seconds to fix that. We are going to use the word orthogonal though, but you'll think of perpendicular when you're doing it. And if you get 0 or 180 degrees, the vectors are parallel. If you get something different, then it's neither. So we're going to take a look at 3 examples of this. First thing you want to do is find the dot product. This is going to be important because if the dot product comes out to 0, you're not going to need to do the rest of your calculations. So here, if we do v dot w, we get 6 times 1 plus negative 3 times 2, which does come out to 0. So I'm just going to write it out. But this is something that you don't really have to do later on, as long as you recognize this. If you don't recognize, not a big deal. But 0 divided by anything is still 0. And then if cosine theta is 0, that means that our theta is 90. And because it's 90, that means that the vectors are orthogonal. Okay, let's take a look at our second example. Again, I would always find the dot product first, in case, like happened before, it comes out to 0. This one does not, it comes out to 26. So after that, I would also find the magnitude of u, and the magnitude of w. So now if we plug everything into our formula, we have cosine theta equals 26 over the square root of 13 times the square root of 52. Now you could put this in your calculator all in one shot, but I just want to show you for this one, it does come down to equal 1. So if cosine theta is equal to 1, that means our theta value is going to be 0, and the vectors are parallel. So far we have one of each. You can probably guess on the next one. They're probably going to come out to some other angle that's not parallel or perpendicular. So let's check that out. I'm just going to move on to another page for it to give myself some space. So again, find the dot product first. That is not 0, so we now also need to find both of our magnitudes. Okay, and then we're going to plug it right into our formula. So there's a couple ways you can do this. You can put it in all in one shot. You can use the fraction tool. You could calculate just the denominator. Anyway, it comes out to about negative 0.716. You do want to use that answer when you do inverse cosine. So we're going to end up getting inverse cosine of that value. Make sure your calculator is in degree mode. Is going to come out to 135.75. You want to keep your answers exact up until this point, like we've done in the past. This would be a neither, because our angle measurement didn't come out to 0, 90, or 180. So that's going to be it for this. You're going to check out another video to look at some other applications of dot product.